Hello students, myself Amrita Dhar, Assistant Professor of Electrical Engineering Department of Greater Kolkata College of Engineering and Management, JIS Group. I will teach you Power System 3. In this video, I have discussed about economic operation of thermal power plant for lossless system. This topic is included in Module 2 of the subject Power System 3. Economic operation of thermal system. Let K be the total number of thermal units connected to a single bus having net electrical load PD. Now let CI represents the input of the ith unit in terms of cost rate, while the electrical output ith unit of the ith unit is PGI. Okay, so it is obvious that the total cost total cost rate is the summation of cost of each of the individual units. So C equals to C1 plus C2 plus so on up to CK. So we can write it in the form I equals to 1 to K C function of PGI. So this is our total cost. The unit is rupees per hour. So here K is the total number of thermal units. And C is the total cost, and PGI is the electrical output of ith unit. Now the objective, what is our objective? Our objective is to determine the criteria of economic loading of thermal unit. What is our objective? Our objective is to determine the criteria of economic loading of thermal units. Our assumption is that our assumption is that all internal losses as well as transmission loss or line loss of thermal units are neglected. This is neglected. Okay. Now economic operation is only possible when an objective function, that is our total cost input, for supplying the net load is PD, will be minimized and subject to specified constraints. So the constraints optimization can be done by assuming a constraint function phi. Constraint optimization can be done by assuming a constraint function phi such that P demand minus total electrical output what is the actual constraint? Actual constraint is I equals to 1 to k PGI max greater than PD. Obviously the electrical output should be greater than the total demand. Though if we neglected the losses, but consider the spinning reserve. So make our output greater than our total demand. What is spinning reserve? That I will describe later. So what is PGI max? Now there is another inequality constraint. There is another inequality constraint that PGI should be greater than equal to PGI mean minimum value and should be less than or equal to PGI max maximum value. So PGI mean and PGI max are the lower and upper limit of the real power output limits of the ith generator. Now again it is assumed that C means total cost is a function of PGI, is a function of real power generation, not and it is insensitive to reactive power generation, that is QGI. Okay. C economic operation is only possible when an objective function, here our objective function is the total cost for input for supplying the net load, total cost of the input for supplying the net load will be minimized subjected to specified constraints. In order to achieve minimum value of the objective function, we use Lagrangian function. Now the Lagrangian function is the conventional way to solve this problem. Now in order to achieve minimum value of the objective function, here the objective function is the total cost, use the Lagrangian function is conventional. The cost function is added to the constraints function phi after the constraint function is multiplied by undetermined multiplier lambda, which is known as Lagrangian multiplier. Okay, so we can write the Lagrangian function Lagrangian cost function is equal to cost function C lambda into constraint function. Now what is constraint optimization function? That is equal to and P demand minus I equals to 1 to K PGI. Now we can write that C minus lambda I equals to 1 to K PGI. This should be minus PD. C bar is C minus lambda into I1 to K summation of I1 to K PGI minus PD. Okay. Now C is the Lagrangian function. This is the total cost. This is the Lagrangian multiplier. This is the output of the ith unit. This is the total real power output. This is the demand. Okay. Now the necessary condition for minimum value of objective function results when the first derivative of C bar with respect to each of the independent variable is 0. So we take the partial derivative of Lagrangian function with respect to output power to get k number of equation for the k number of plants operating in the system. So thus for ith plant, this is equals to delta C bar by delta Pi. This is equal to 0. So we can write d delta Ci by delta Pgi minus lambda is equal to 0, because delta Pgi by delta Pgi is 1 and Pd is not a function of Pgi. So constant derivative of constant term is 0. So we can write only lambda here. So the first derivative of the cost minus Lagrangian multiplier is equals to 0. So what is the value of lambda? Lambda is equals to dci by dpgi. Ci is obviously a function of pgi. Okay. So dci by dpgi is the incremental cost of the ith generation. So this is the incremental cost of ith generation. Okay. So the necessary condition for the existence of a minimum cost operation condition for the thermal based energy generating system is thus obtained by this equation when the incremental cost rate of all the units is equal to the Lagrangian multiplier. So for k number of such units, economic operation is thus attained when delta C1 by delta Pg1 equals to delta C2 by delta Pg2 equals to delta Ck by delta Pgk equals to lambda. So optimal loading of generator corresponds to the equal incremental cost point of all generators, called the coordination equation. Numbering k is solved simultaneously with load demand, and to yield a solution for the Lagrangian multiplier lambda, the optimal generation of k generators. Physical significance of lambda. Physical significance of lambda. Now for incremental changes in power generation, for incremental changes in power generation delta C is equal to summation I equals to 1 to k delta C by delta PGI to the power 0, that is initial value, into delta PGI. Now at optimal operating point, delta C by delta PGI equals to derivative of C with respect to PGI is equal to incremental cost, the initial value of the incremental cost, into lambda. Now delta C is equal to lambda from I equals to 1 to k delta PGI. Now we can write that total electric power generation is equal to total power demand if there is no spinning result. So we can write from this summation I equals to 1 to k delta PGI equals to delta PD. So delta C equals to lambda delta PD. So lambda equals to delta C by delta PD. So what is lambda means? Lambda means the incremental cost for unit incremental change in the load demand. The incremental cost for the unit incremental change in the load demand. This is the physical significance of lambda. Now this equation is called coordination equation. Numbering k is solved simultaneously with the load demand. Now this equation to yield a solution for the Lagrange multiplier lambda and the optimal generation of k generators. We establish the procedure for delta in equation dC1 by dPg1 equals to dC2 by dPg2 equals to dCk by dPgk equal to lambda. Now if the cost curve are quadratic, then the problem reduces to the linear case. In general, the incremental cost curve may not be linear and lambda can be determined by the iterative process. Now computer solution for optimal loading of generators can be obtained iteratively by considering the incremental cost curve. Now as shown, you can shown in this picture. Now the steps are: first, choose a trial value of lambda, that is IC equals to IC 0 to the power 0, that is the initial value of the IC. Next, solve for PGI where I equals to 1 to k. From equation Fi equals to Ai plus Bi dash into PGI and Ci equals to Ai plus Bi into PGI. The third step is, if summation PGI minus PD is less than a specified value like epsilon, the optimal solution is reached. Otherwise, increment IC by delta IC if summation PG minus PD is less than 0, or decrement IC by delta IC if summation PG minus PD greater than 0, and repeat from step 2. Now this is possible because PG is monotonically increasing function of IC. Now consider the effect of generator limits given by the inequality constraints of equation PGI mean less than equals to PGI less than equals to PGI max. As incremental cost is increased or decreased in the iterative process, if a particular generator loading PGJ reaches the limit PJ min or PJ max, its loading from then on is held fixed at this value, and the balance load is shared between the remaining generators on equal incremental cost basis. The cost function of a 50 megawatt generator is obtained as CPGI equals to 225 53 PGI plus 0.02 PGI square into 10 cube rupees per hour. Now calculate first incremental fuel cost. First calculate incremental fuel cost expression. Next, incremental fuel cost when 100% loading is applied. And third one, cost when 50% loading is applied. What is the solution? First, it is given that CPGI is equals to 225 plus 53 PGI plus 0.02 PGI square. Now, what is the expression for IFC? What is incremental fuel cost or incremental cost? It is first derivative of the cost with respect to PGI. So it's 53 plus 0.04 PGI Okay, so this is the answer of question A. Now we solve for 100% loading the value of IFC. IFC is equal to 53
plus 0.04 into 100 into 10 cube. This is equal to 55 into 10 cube rupees per megawatt hour. Next, for 50% loading, 53 plus 0.04 into 50. So this is equal to 10 cube. This is equal to 54 into 10 cube rupees per megawatt hour.
That's all from today's class. If you have any problem, please contact with me. My contact details is given on the first slide. Thank you.